Hello, my name's Alan Fu, and today I'm going to talk about renewable electricity in America. So, comparing forecasts and perspectives for wind and solar in the United States. So, on the left-hand side, you have forecasts for wind and solar relative to 2018, and you can see in almost all of these cases you got significant increases, in the high case up to 5 times as much. And on the right-hand side, you see potential evolution, both my own work and forecasts from the EIA and the IEA, two different public forecasting organizations. So, past renewable forecasts have been very over-optimistic. So this is a chart taken from JP Morgan's 2021 Energy White Paper, which came out a couple of weeks back, and shows that basically a lot of people have forecasted extremely rapid growth for renewables, which they define as wind, solar, hydropower, geothermal, biomass, wood and waste, so basically everything apart from nuclear and fossil fuels. So you can see these things, they're forecasting over 50%, some of them very rapidly, but this hasn't happened. So this is the actual share of these particular energy sources. So why has this been happening? And what's the real picture? So why have these forecasts been over-optimistic? Now, they've tended to have come from people who don't necessarily work in the energy industry. Tended to be academics, some of them tended to be politicians, some of them tended to be people from other walks of life. They've all tended to come from the left side of American politics. Now, America, sadly, is a very divided country. We have the left and the right, and never the twain shall appear to meet. And the people who will be making these forecasts tend to have a bit of an environmentalist bias, so they want to displace fossil fuels. So quite a lot of wishful thinking involved with that. And it's a narrow group of people, and they tend to have quite a bit of clique think and lack of diversity of thought. Now, the right side of the argument also happens to have a lot of clique think and lack of diversity of thought, and a massive media echo chamber on both sides. But the problem is, if you don't hear what the other side's saying, you don't question what you're saying, you come up with a very narrow answer. So the other thing is the incomplete understanding of the whole energy system. So energy is not only electricity, and a lot of people outside the energy industry make that mistake. So please don't, and I'll explain why. So this is a chart produced by Lawrence Livermore National Laboratory, a major US research institution. So they use the quad, or the quadrillion British thermal units, as a unit of energy. There are all sorts of different energy units that are used: joules, barrels of oil equivalent, tons of oil equivalent, etc. But they use quads. They're all kind of interchangeable, and the conversion factors for all of the above, so let's just stick with what they're using for the time being. The fact that they use quads and the way it adds up is quite handy, because America uses about 100 quads of energy, so this makes percentages really easy to calculate. So when you see here, as electricity uses 37% of US energy, so the other 63% goes to everything else. Electricity uses almost all of solar, well, all of solar, effectively. I know there's a little bit of solar water heating, all of nuclear, all of hydro, although there are some hydro-driven mills, all of wind, all of geothermal, sizable chunk of the natural gas, virtually all the coal, and some of the biomass, but very little oil. So when people talk about renewables displacing oil, well, it doesn't kind of work, because oil isn't used for electricity and renewables are used to make the electricity. So unless you have massive electrification of all of this above, no, that's possible. Oil is the last thing that's going to be displaced by renewables. More likely to be coal, more likely to be natural gas. And this is roughly what they tend to forecast, mostly coal that's going to be displaced. Okay, so US uses 37% of their energy system for electricity. What about other countries? So Lawrence Livermore also did this piece of work which I've charted up, but that was done back in 2011. They haven't really updated it much since, so some things would have changed a little bit. So US users used at that time roughly 40%. So, and it hasn't changed much because they produced an annual for the USA. A little bit more in some countries. So for instance, France and Russia tend to use a bit more electricity, where some other countries like Brazil, Ghana, Nigeria tend to use a little bit less. They will use more as they develop. So you see where Mexico is, you see where Bangladesh is, and it's going to move in this direction, but there seems to be a hard ceiling of around 50%-ish. I can probably envisage somebody like Russia going a little bit less because more people will buy cars, therefore there'll be less of a share, but that seems to be the rough ceiling as it is. Now, France is so abnormally high because they tend to use also electricity for space heating, having nuclear power. So electricity is not energy, so let's put that one out of the way. So what's about the share of wind and solar in electricity generation? So this is some work from BP Statistical Review of World Energy, which they publish every year. This is based on the 2018 data, and you can see European countries such as Denmark, Ireland, Germany, Spain, Portugal, and my home country, the United Kingdom, being very high wind and solar users. Ireland, mostly wind. Anyone's ever been there kind of sees that, whereas Spain tends to be a little bit sunnier. Germany tends to be quite keen on solar as well, although they're not an ideal climate. Whereas if you look at other countries, you go further down the hill, France has relatively low wind and solar, but as I mentioned before, they're mainly nuclear. And the United States, roughly 7 or 8% of their electricity is generated by wind and solar. So towards the middle of the pack. However, they do generate a lot of electricity, so they're number one or number two in many of these cases because of their sheer size. So let's try to see what more realistic forecasts look like. So EIA, the American organization, Energy Information Administration, publish an annual outlook for US energy use. They published one just recently in March, the 2021 outlook. So according to that, renewables are going to grow significantly. So wind and solar is going to go to about 13% of the energy system in 2050 versus 4% in 2019. If you look at wind, solar, hydro and biomass, i.e. the non-nuclear, non-fossil, they'll go up to about 18 versus 10 in 2019. So that multiplied by 4 times, that almost doubling. And that kind of compares to the work that I've done myself as well. And I'll talk a little bit about that later. So these are the forecast shares, the pie charts from 2019, 2050. So what you can see from that is the renewable shares grown up quite a lot. Squeezed out coal, a little bit of squeeze of nuclear, a little bit of squeeze of hydro. Gas, sort of similar. Oil, virtually unchanged. And when you look at absolutes, you've got a situation where oil, virtually unchanged. Gas, a bit of growth. Coal, significant decline. Nuclear, a bit of decline as older plants are decommissioned, to be followed by newer, and newer plants don't arrive in time. A little bit of decline of hydro. A little bit much decline of growth in biomass, massive growth in wind and solar. And when you look at that, again, as absolute units from 2020 onwards, again, 2020 has been significantly depressed by about 8% versus 2019 due to the COVID epidemic and reactions to it. And it'll recover by about 23, 24 all in, according to the EIA. But between 2019 and 2050, only an 8% growth in absolute energy use, despite a forecast 15% of growth in population, according to the US Census Bureau, hopefully significant GDP growth. So the US is becoming more energy efficient, getting more bang for the barrel, and getting a better deal. Now, renewables, you can see significant growth, a little bit of growth in gas, etc., which we broke down earlier. So that's what EIA reckons is going to happen. If you look at wind and solar over time, so I've done a little bit of work on my own, which looks at per capita wind and solar usage multiplied by population with low, medium and high cases for all of the above. So the red line is my forecast for low case use. Okay, kind of not too bad, nearly doubles on where it was, but relatively slow growth. The blue line is roughly what I think is going to be the mid case, so that's the average of all the cases, and the green line is the high case, so that's high population, high per capita usage. So you've got a fan coming out of a central point. These two lines are the EIA, the 2020 forecast and the 2021 forecast. You can see 2021 as being become a substantial increase over 2020. So clearly they're believing in renewables being a bigger part of the US pie. And it's kind of close to where my mid case is. So that gives me a bit of comfort. And the stars are the IEA, the International Energy Agency, who are based in Paris. And they have two scenarios. A stated policy scenario, which is effectively evolution from where you are now, with policies the governments have already agreed upon, and sustainable development, which is a more rapid technological change scenario. So again, their stated policies is a little bit lower than I would have it, and their sustainable development is sort of fairly close to where I have the my mid case. Again, IEA don't publicly put out the spreadsheets. You can buy them, so this is read off their graphs and to try to understand where they are. But it's within the ballpark of where I see and where the IEA sees it. So again, substantial growth. So great. So what effect is that all going to have? Other thing that's come out recently, and again this is from the JP Morgan Energy White Paper, is the Biden plan for halving emissions. So these are greenhouse gas emissions. So this is not just CO2. This includes methane and others in CO2 equivalents. So historically what has happened is they've gone up until about 2007, 2008, to the Great Recession and advent of fracking and displacement of coal by gas in US power generation. Then there's been a steady decline with, a little bit of a sawtooth and kind of a bit of a flattening off recently. Biden aims to halve it relative to 2005, which was the peak, by 2030. As you can see from that, this is a bit of a tall order. And one needs to wonder where it's going to come from and how they're going to do it. Other thing to bear in mind is energy is not a pure federal matter in the US. Now, a lot of people who are not Americans kind of find that a little bit difficult to grasp. So the states, the individual states and perhaps the individual districts have a great deal of influence on what goes on within their particular jurisdictions. So the state of Texas regulates the Texas electricity industry, for example. So different states, red states and blue states, are controlled by different people. So how much would they go along with any federal plans, and what influence do the feds actually have? Again, interesting question. When you look at emissions history and forecasts, so these are my forecasts for CO2 emissions for the USA. Again, the black line's history. This is CO2 only, not all greenhouse gases, although the two tend to mimic each other pretty well. So again, rise till about to the Great Recession 2007, decline since then, based to some extent on economics and to some extent, to a great extent also on fracking, replacement of coal to gas. Now what happens next? Okay, a little bit of an uptick then since then. Obviously there would be a significant fall in 2020, but that's not recorded here because I don't have the data yet. And you have these particular situations. So you have a black line, which is the high case, the blue line, which is the mid case, which is effectively kind of flat, and the green line is a decline. So overall that will decline roughly by 2040, roughly a third from where it would have been from their peak. Now, of course, these could change, but in order to get to here, you need radical change. Business as usual isn't going to do it. Now, in order to get radical change and to implement it in such a short time, you need consensus across society, across politics, across industry, etc. Now, in Europe, there kind of is that consensus because you have that. You don't have that, however, in the United States because of the red and blue divide. This is per capita emissions and CO2. So this is CO2 looked at on a per capita basis. So this is the Biden plan relative to where it was. So you basically have to have 54% of emissions from in 2030 per capita of 2005. So the key points are the renewables industry in America has made tremendous achievements. It's gone from nothing in 2000 to 4% of the US energy. And when you think about the scale of US energy, it's enormous. 7% of US electricity. Most forecasts predict this significant growth in the future. Both myself, both IEA, EIA, everybody. But renewables only generate electricity. And electricity is not all energy. The renewables do have issues with dependability and intermittency, as we've seen in Texas recently in the Great Texas Freeze. And it could be a ceiling to share renewables can have in an energy system. The other danger is that renewables advocacy is driven by ideology. In an ideological country, that is difficult to manage because different states, red versus blue, will they work together? How will happen? We don't know. So to sum up, we've got this graphic, potential for wind, potential for solar, and then changes between 1990 and 2017 where renewables are and how electricity is generated. So The coal will decline. Quite how everything fits in, we don't know.